family, it's Dr. Mommy here. Sorry for the delay. We actually had to move quite a distance. Part of the reason I'm filming this in my car. I've been working very diligently on the class 3 materials. What I'm showing you is not the final version. I'm going to 3D print something so it'll be a little easier to inject different liquids to see the refractive index, and hopefully you can kind of line up the different lenses and see how that affects the laser light, or the image ultimately that you're trying to magnify. And so your assignment is start simple and just use a laser pointer or something and see how the lenses with different liquids in them bend the laser lights. And if you're feeling really ambitious, you can line up the different lenses and see if you can see something very small, maybe even microscopic. And I cannot wait to hear all about it. So please, in the comments, write in complete sentences what you're able to see with your lenses, and what substance you like in between your lenses and why. I'm very, very curious. All right, have fun. All right, so this is the first lens we're gonna try. You can see I just have like a rubber washer and a couple of pieces of flat PET plastic and water in the middle. And did I have trouble getting it to not leak? I sure did, but it'll do for the purposes of the demo. So first thing I'm gonna do is try to aim my laser, which is surprisingly challenging. So can you put a dot right there, my love? I'm gonna try to keep it steady. All right, and now I will use the yellow marker. Do you want to move it?
Ready?
Yeah. Okay, you're gonna move it in front. Doing beautiful. All right. I think it's hitting the... Here, can you move it back a second? I don't know if I'm getting in the middle of the thing. Okay, move it back just a little bit more. This way. This way. Perfect. Okay, go ahead. Where's it going? Oh, staying right there. You are doing beautifully. Yep. Yeah. Perfect. It does kind of scatter just because it's not a very clean lens, but that was beautiful, honey. Thank you.
Yeah.
So this lens is plano concave. So it kind of caves in on this side and it's flat on that side. So we're gonna do the same thing. Aim a laser, try to keep it steady. Okay. There we go. And you ready? So how about we start with the concave side facing the laser, or facing the camera? Okay. I think I'm getting like your fingers instead of the... Do you wanna try again?
Sure.
Yeah, go ahead. You're doing great. All right, so, oops. I have the... Oh yeah, you're doing great. So, all right. Now it's here. Keep pushing slowly. I'll try to follow you. All right, can you go back the other way just really slowly? There it is. And yeah, all right. Thank you. So when you had it, let's see. So let me see if I can aim it again. So when you had it kind of on this side, it was bending that way. And when you had it kind of on this side, let's see if I can aim it again. It's always tricky. It was kind of bending. Let's see if I can aim it. That way. So now the plano convex is flipped so that the flat side is facing the camera, and the convex side is facing where the laser dot's going. Okay, We see. Oh, kind of the same thing. When it's over here, it's aiming that way. And when it's going through this side, it's aiming that way. Very good. You have a mustache on your face.
I know I do.
Right. So this is plano convex. So it's flat on this side and it's sort of bulging out on this side. So where's that light? Oh, you've got all right. So what color am I gonna use?
Ow!
Ooh, are you all right?
Yeah.
All right. So I think I'm gonna use maybe green for this one.
Okay.
Okay.
Yeah.
Actually, I'll use pink.
Yay.
All right.
Why is it wet?
Because it's leaking. Don't worry, I'll fix it. Okay, so hang on. Gotta aim it.
The back.
I know the battery's not happy with me.
It's kind
Is your? I don't think your finger might be in front of it. Here, let's try again. Okay, so move it just a little bit this way. I'll try to aim. Okay. All right, there we go. So, yeah, I think it might need to be a little bit this way. Okay. Ah, okay, go ahead. Do your thing, babe. Should we see again? See if I can. Ah, yeah. Okay, so I don't know if you saw it that time, but when you had it at this edge, right? The light's going through this edge here. It was aiming that way. It's the opposite of the convex or the concave mirror, right? When it bulges out and you get on this edge, it aims in the opposite corner. Anyway, well done, dear.
Yeah.
I don't know if you want to try the other way around with the plane. Well, I'm going to try it. Let's see. Okay, so now the plane is facing the dot and the convexity is facing the camera. And oh, same thing. Nice. All right, so this one is double convex, so it's sort of, or double concave, so it's caving in on both sides. So, there's our laser right here. Okay. Aiming, and all right, so it's on the edge further from me, and it's aiming still further away from me. And as I move it to the edge closer to me, it starts aiming closer to me. Let's try again. There's the light. Away, middle. Oh, there we go. All right, so the last lens is double convex. It bulges out on both sides. Getting the laser. Aim it. And corner for this from me. Aims in the opposite direction. Now in the middle. Corner closest to me. Aims further away. A lot like our plano convex. So at this point, you might be wondering a couple of things. One, what happens when you have, two different shaped lenses in series? How does that affect the image? And the other, like how far apart do you need to put them in order to get something clear? What does the image then look like? And the second question you may be asking is, what happens if there's something in the lens other than water? If it's air, you're probably gonna get not much, but you might try something like isopropyl alcohol, which you can get at a drugstore. And I'll make sure to have apertures where you can fill it with stuff other than water, and see, if it bends the light more or less. Now, more to say about that presently. Maybe you'd be wondering why the lenses have to be filled with something like water or isopropyl alcohol. So to demonstrate that, I've got this glass vase. It could be made of the PET plastic that we use in our lenses. But you can see behind it that the lines on the paper are more or less parallel. So watch what happens. And I fill it with water. Now you can see that the lines are not parallel, right? They're really bent. And it has to do with the way light moves through water or isopropyl alcohol or something else, relative to the air. An illustration of refraction can be done by making a rainbow, and you can do that with a pan of water and a mirror submerged in it. So I'll try to show that. And if you can see the pretty rainbow there, and the blue on the bottom and the red on the top. And I have to try to move the pan with my feet so you can see. If you shift the water, you change the shape of the rainbow. You're not exactly altering the refractive index, but so the reason I bring this up is because I actually mentioned this experiment in a lot of my, I'm shifting the rainbow. I'm trying to keep the light steady so you can see that it's just the water that's shifting it. But yeah, I actually talk about this in a lot of my presentations when I'm talking about, biolayer interferometry or surface plasmon resonance. Those both use a beam of white light that goes through these substances that will bind a particular molecule. And the more that molecule binds, the more you're essentially shifting the water, the pan of water, and shifting the shape of the rainbow. And their detectors can actually detect that shift and thereby very sensitively detect how much of the molecule is binding and therefore the concentration of the molecule in your sample. So, I mean, as kind of fun and silly as this may be, it's actually demonstrates a very, very useful technique that's often used in biology.